In this video, we will discuss about the 2's complement and construct a Turing machine for the 2's complement. Let us consider any string which is in the binary format. Let us example 110101. This is the string which is in the format of the binary. Now the 2's complement of this string is 1 remains as 1 remains as 1. Wherever we get the first 0 in any binary string, whenever from left to right, whenever we reaches the first 0 until we make this ones as ones, whenever we reaches the first 0, this 0 replace as 1, and from the rightward these terms are, we write the ones complement for these terms. The ones complement of 1 is 0, ones complement of 0 is 1, ones complement of 1 is 0. This is the 2's complement. Let us see another example. 1011, which means the 2's complement is 1 remains as 1. The first 0 from left to right is here. Now we make this 0 as 1. The 1's complement of 1 is 0. The 1's complement of 1 is 0. This is the 2's complement of. This is the 2's complement. Now we construct the Turing machine. Let us take an example string which is 110101. This is the string we can consider. First, until we get the first 0, these ones can be represented as ones. After we get the 0, this 0 can be represented as 1. This whole part we can apply ones complement. This 1 represented as 0, 1 represented as 0, 0 represented as 1, 1 represented as 0. Let us see the Turing machine. Q0 is the initial state. If we get 1, this 1 represented as 1 and it moves in the direction right. Now the pointer is at here. The 1 remains 1 and it moves to the right. Now the pointer is at here. This one also remains same 1 and the pointer moves to the right. Whenever we got the first 0, this 0 represented as 1 and moves in the direction right. This 0 represented as 1 and we can move to right in direction. Now the pointer is at here. This Q0 changes to Q1 state. Now we can apply ones complement to the all right side elements. Now here it is the 1. This 1 changes as 0 and the pointer moves to the right. This 1 changes as 0 and the pointer moves to the right. Now the pointer is at here. This 1 changes as 0 and moves in the direction which is the same. Then this 1 can be changes as 0 and the pointer moves to the right. Now the pointer is at 0. This 0 represented as 1 and it moves in the direction right. This 0 represented as 1 and it moves to right. Now the pointer is at here. This 1 represented as 0. The next pointer moves to here. From this Q1 state, whenever we get the blank symbol, this blank represented as blank and the direction moves to the right. In input type there are infinite number of blanks can be present. Now the state Q1 represents to Q2. Whenever we reaches the blank, then it is the final state and we place the self loop for the blank which is represented by blank and the direction is R. from the state q1 to whenever we reaches the blank, then it is the final state for the 2's complement. Now we write the transition functions for the 2's complement. For q0 we can give input as 1, which goes to same state q0, and 1 can be represented as 1 and direction in right. Now in q0 when we apply input as 0, then this q0 goes to q1. What is the then 0 can be changed into 1 in direction r. Now q0, these are the transition functions for q0. Now we write transition functions for q1. For q1, if we apply input as 0, then it remains in the same state and gives the output 0 and moves in the direction right. In the same q1 state, when we use the 0 as input, then it remains in the same state q1 and gives output as 1 and change the direction into r. In this q1, if we apply blank, then this q1 changes to q2 and blank is replaced with blank and the direction is changed to r. Now the transition function for q2, when we apply blank as input, then it remains in the same state q2 and the blank replaced with blank and it is move in the direction r. This is the Turing machine for the 2's complement.